doing more of that silly math talking. Let's see what the actual purpose and what we use error bars for in biology. Most of the time, we're wanting to look at two pieces of information, and based on what we know, we want to say, are they different from one another or not? So, here's what your eye tells you. Hey, here's the mean, for this is whatever 1 is. We're going to compare it to 2. Here's the mean. Yeah, they're different, right? They don't have the same mean. They're different. That one's more than this one. Are you sure? Like, how sure are you that they're different? So what you're really saying when you look at these, for one, is this is information that belongs to a bigger set of information. This mean is part of a group of means that fall from here to here. This is just one of the means of all of the means that fall from here to here. So one's like, hey, I belong to a group that has information from this amount to this amount. And two's like, cool, I belong to a group too, and my information ranges from here to here. Look at that. Like, that's so cool. We're the same right here. This means that they belong to the same group, that they're just a different measurement that could belong to the same group. So they're not different. So for this one, we would say this is not significant. We can't say they're different. If you're trying to sell me this one, because of the low amount, there's no difference between 1 and 2. So that's the take home. No difference between 1 and 2. Over here, you're measuring. You've got the same, hey, I'm 1, and this is my mean, and the means I belong to, the group, run from here to here. This one's, oh, cool. We overlap. Well, not much, like, at all, but we do. So at this point, any overlap at all means that they're probably no different from each other. Although we're getting to where this is more iffy. Like, you could say that the differences between are not significant, because significance is either it is or it isn't. But you may need more information. But statistically, there's no difference. This is where you start thinking, I need some more data. What about this one? Hey, I'm group 1. Here's my mean. I belong in a group of means that range from here to here. Really? I'm group 2. Here's my mean. I belong in a group of means, and they run from here to here. Oh. Well, That's unfortunate. We're not in the same group, are we? No, like mine stop here. Yeah. Mine, like, don't start till here. So if there's no overlap, then there is a significant difference. And you could say, yeah, there's difference. So what might be this is what we did. We got this measurement when we, let's say, didn't do the treatment. And over here's the measurement we got when we did do the treatment. Oh, well, they're different. That treatment made a difference because your means don't belong in the same group. So here's this just little joke where that you've got this little guy that says, here's my mean. I belong in a group of means from here to here. Oh, We don't belong in the same group. Oh, but we do. We belong in the same group. Barely. Well, I belong in the same group as the first guy. I belong in everybody's group. How do you belong in everybody's group? I'm pretty sure if you belong in everybody's group, but everybody doesn't belong together, you're just not sure about anything. So this piece of data right here is no good. And it says, sorry, we just can't trust you. Because the information you're giving, it doesn't tell us anything. So you look at the error bars, and if they overlap, then those pieces of information came from the same group. So let's look here. If we look at calcium sensitivity, and we've got a lot of variation, so the means in this group are really different from each other. So that's one thing I can notice. So you've got high variation in your data. Here you've got very small error bars. So you've got low variation in your data. The data you took, all of the data information is very similar to one another. Here you've got, again, a lot of variation, even more than you had in this first phosphate group. However, they all overlap each other. So technically they could all belong to the same group of means. And the group of means just means the population. So here, there's no significant difference in the calcium sensitivity of these three groups. So that's what I would say. No significant difference in what did I measure? The calcium sensitivity. And then you would say what your three groups are. Of the three groups, I guess in the main, I pulled these out of context, so it's hard to know, matrix, and that would be phosphate, oxalate, and uric acid. They're the same. They're not any different from each other. So different conditions did not make the calcium sensitivity different. Although, you sure do have a lot of variation in that data. Like, there's a lot of differences in the measurements around uric acid. Not a lot around oxalate. So let's look here. So you got a bunch of food brands for fish, and they all say they grow big fish. Okay, well, let's see about that. Let's measure the fish. So they measured the fish, and they had fed these 4 different types of food. So I can say, from looking at these, that group 1 overlaps with group 2, which overlaps with group 3. All of these overlap. So there is no statistical difference, significant difference in 1, 2, or 3. Don't try to sell me 3 and tell me it's better than 1 or 2. It's not. Also, I can say that there's no difference between 2, 3, and 4 because they all overlap. The only brands that could really compare themselves is that 4 could compare itself to 1 and say, this is my mean. I belong to a group of means with this range. This is your mean, and your group does not include my group. So we're different. We're in different groups from each other, which means there is a difference. So the difference is between 4 and 1. So you could sell it if you were 4 and say, hey, there's a difference. So now we're looking at root length, and we're going to compare these two. Now I picked this one on purpose. They don't usually give you ones like this. But if I say chemical 1, the mean length is here, which is 30, and it belongs in a group of means that run from 20 to 40. Chemical 2 has a mean of 50 centimeters. That seems a lot longer. Like, shouldn't that be way different than 30? No, actually it's not. Because they share with their group the mean around 40. So even though they overlap just like that one place, they do overlap, and there is the possibility that you could have within this group that this one belongs to, you could have an upper extreme and this one have a lower extreme, and these belong to the same group. So it's really hard to say this because you don't want to, but they belong to the same group because their error bars do overlap. Now, I would want more information for sure, but I would say that it appears that there is no significant difference between what did I measure, the root length, and this is, I guess, when treated with chemical 1 or chemical 2. There's no difference in the two. Now, they don't usually give you stuff like that. I just try to go find stuff so you can see. Okay, hello, versus can't be this hard. All right. You don't have to do bar graphs. Here, we're looking at heart rate, the mean heart rate. So we've got a bunch of participants. We take their heart rates, we take the average, and we plot it right here. Those are the means. We see that they're steadily increasing based on the number of jumping jacks they do. So at the beginning, when there's no jumping jacks going on, this would be times 0. This is your resting heart rate. And then you let them start jumping. So after 5 jumping jacks, 10, 15, 20, 25, you see that the means steadily increase, and there's not a lot of variation as you get farther into the exercise around the means. So there's more variation here, and you could start looking to see if they're different from each other, but overall what really matters is compared to when you started, which is I haven't done any jumping jacks, to when you did 25, obviously if, hey, I'm the data point for the heart rate at time 0 and I belong to a group of means that range from here to here, by no means do you belong in that group. They are significantly different. So you could say after 25 minutes, there is, let's write this out. There is a significant, and if I know what the difference is, let's call it increase in what did I measure in heart rate based on what conditions? Based on the number of jumping jacks. And I guess it's not 25 minutes, is it? It's after 25 jumping jacks. There's a significant difference in heart rate. After 5 jumping jacks, is there a significant increase? Nope. Because they belong to a group of means which includes each other's data, even if it's barely. So there's no significant difference after 5 jumping jacks when you compare it to time 0. What about for when there's 10? So this would be no. This would be yes. You start to have your difference, and then the rest of these all are different as compared to the resting heart rate. This would be your control. Everything's the same. It's the same people, the same way you're measuring, the same machine, the same everything. The only thing is there's no treatment, and the treatment is the jumping jacks. So this would be what happens as you go. For the next one, you're looking in 4 different regions, and you're comparing, even though you can't tell, males and females. You're measuring something that they do. And here you can do either comparison within the region between the males and the females, or you can compare all the males over the different regions. There's a lot of things you have to pay attention to what the question's asking. So if the question was, is there a difference between males and females in the, I don't know, I'm going to make this up, number of push-ups in these different regions. What's your answer here? Your error bars overlap, so that means that you could have in this middle area right there, that's where your means could fall. So here there's no difference. These, you can see why I went and picked these, and then they make me grumpy. These right here, I mean, overlaps and overlap no matter how much. No, but I would want some more information. Here, this group of means that the male data belong to, and this group of means that the female data belong to, they don't overlap, so they're different. And if they're different, then these groups are different. So yes, there's a difference in the number of push-ups in region 3 between males and females, but not here, not for region 4. So maybe if that's the case, maybe you'd want to go, hey, region 3, why don't you go see what's going on with the other regions to see what they're doing, because it looks like that the females can do as many push-ups as the males, but not in your group. How come? Then they can be messy, and they don't have to have 2 at a time. So a lot of times what you'll see is they'll plot 2 different treatments with a control, and in here, this is really weird. It's like advertising, and they remove the deceptive piece, and here I guess here they remove it and here they don't. And then they measure something. But to tell you the truth, I don't care. What I can tell you is when it comes to total ads, there is a significant difference in what this is, this VMPFC, compared to the other 2. So that would be the difference. And in here there is, and in here. So across all of this, this is significantly lower. This VMPFC is significantly lower. Now, when you look at the other groups between what is this, BDC and normal, so there's no difference between those 2 conditions, no difference here or here. So nothing you did made a difference between those 2 groups. So this one I picked on purpose, and it's a horrible copy because I blew it up a lot. So it's the average scores of boys and girls on a test. So the average score of boys, I think this is, I don't know, I'm going to make it up because I can't read those numbers. Let's say it's like, look to be like around 72. And then here would be, I don't know, like 77. And you've got a teacher running around going, there's a huge difference. You should be doing more. These boys, they're not working hard. She needs to hush. She's wrong. She's wrong. Because when you look here, first of all, the boys all scored really close with each other. There's not a lot of variation. The boys are pretty much all scoring 72. The girls, on the other hand, are all over the place. Their scores range from really good to really awful. And their mean is 77. So yes, their mean's higher, but their error bars overlap, so there's no difference between the 2. I'd be more wanting to go, hey girls, what's up? Like, what's the difference between why did some of y'all really get it and some of y'all really didn't? The boys all seem to understand about 72-ish%. Y'all were all over the place. So, on that same note, here's a question that says you've got 2 different biology teachers, they gave the same test, and you've got the teacher's data is for here's class 1 and this is class 2. So this teacher, if you notice, this is below here. So it starts here and this one starts there. So they do not overlap. She needs to see what's going on with class 2 because these are different. The performance of class 1 is different than class 2. Now teacher 2 may want to get on her high horse. I used to say that. I never understood what that meant. But anyway, she may want to start fussing at this second class, but she needs to hush. Because statistically, the group of means that this first class belongs to and the group of means that this class belongs to overlap. So there is no difference. Even though she wants to say that this means lower, it is. That's true. There's a lot of variability around both of these. Like her class data is all over the place for both of these. Like she's got really a whole bunch of low scores, a bunch of high scores. They're all over the place. Overall, though, class 2 in general had a lower range. So that would tell me that their understanding as a group is lower than this group, and that I would want to work with them. But there's no difference between the actual means of those. So here we go. This is the one that's very typical. This looks much more like something that would come on an exam. So I've got enzyme activity measured here, and I've got a group that I did not treat that's exactly like this group that I did treat. And so it looks like the enzyme activity based on the treatment is significantly lower because they don't overlap. So you move from saying those are different because they don't, the error bars don't overlap, to being able to now let's make a statement. So I would say there is a significant difference in what did I measure? Enzyme activity. And what are your groups? Between the control group and the treated group. So if there's a difference, what is the difference? So you would say with treatment, the enzyme activity is lower, and it's significant. Let's look at this one. So this is a data table, and they tell you that there's a student who goes, hey, have you noticed that the leaves on one side of the building are bigger than the other? Really? Yes. So he measures 30 leaves, and he's looking at the width. Here's the width that he took 30 of them, and he got the mean for the shady leaves was 7.43, and the mean width for sunny is 5.88. It's like really weird, but anyway. And you use standard deviation to find standard error. So to find this number, all he did was take his 1.63 and divide it by the square root of n, and that gives you this number. So standard error gets to be super tiny the more leaves that he measures. Because what you're saying is, how different is your mean from the other mean in the group? Well, the more leaves that you measure, the more you're going to be like the group, because the group's getting just huge. You're measuring more and more of the group. We have more information. So this is about your mean compared to other means. So here's what you do. This is what's important right there. They want you to take the mean, and you're going to graph these on the same graph paper, and you're going to go up to standard error of the mean, so up 2 times 0.3, and down 2 times 0.3. So let's think about that. So if our standard error is 0.3 and we go 2, our error bars are going to be 0.6 above 7.43. So I would take 7.43 plus 0.6, and I get 8.03 as my top. And I take 7.43 minus 0.6, which is what? 6.83, and that's going to be the range of my error bars. Do the same thing here. I'm going to take 0.24 times 2 is 0.48. So I'm going to take 5.88, and I'm going to add 0.48. So that's what? 5.96, 6.36. Wow, this is when I need y'all. And then 5.88 minus 0.48, and you get 5.4. Okay, so they graph them here, and that's what you get with the error bars. They're tight. The standard errors are small. So at this point, what the real question is there a difference between the condition of shady and sunny? That's what they're asking, always. These two things that you're comparing, are they different from one another? And your answer here would be yes. You would say there is a significant, and what did we measure? Width. And what does this one's higher, right? So there is a significant increase in the width of the leaf, so the leaves, between the two conditions. On the shady side versus the sunny side. So it's because they do not overlap. They do not overlap. They don't belong to the same group, which means they're different. So there's a difference in shady and sunny. Well, what's the difference? The shady's higher than sunny. How much? Significantly higher. Higher, what did you measure? The width of the leaves. So that's actually doing it. We're going to have a free response question that we do this with. But I want to bring up the one that we've seen before. Here's our, let me find it. Hold on, I'll pause. Okay, so now let's go back to our first question we did. And we're going to look at time 0 when he plopped all the guppies from, I don't know, 11, 16, I don't remember, locations. All different. So, yeah, I would think they should be really different. Really different what? With their number of spots, because that's how he measured. And so this mean of 10 belongs in a group of means that range way up here close to 12 and way down here close to 8. So lots of variation in this particular population at this time. Now, let's go over here to 6 months later. And we now have very little difference because your group means, this is what, close to 12, belongs in a group that's really tight. Like there's not much variation there. But what we didn't have to do, and what we could have done, is we could have said this, but there's no significant difference in the number of spots between 0 and 6 months. It's prior to the actual split, and here's the reason why that matters. These little guys are the offspring of these little guys. So I would expect that if they had this much genetic variation, that this group would fall within what its parents came from. Then we split them, and we begin to see what happens. So let's look at these now at different times. So at 6 months, there's no difference, significant difference really, between the spots at 6 months and at 0, because their error bars overlap. But if you look between 6 and 14 months with the predator, these two groups, their error bars do not overlap. They're from just different groups. We can say they're significantly different. Same thing here. They are significantly different. If you look at all of the data as a whole, there's no difference here with the predator than at the beginning, because we had so much variation at the beginning that we have the ability then to have a tightening of our number in response to the predator, but we still had that type of genetics in the gene pool here. So these are just responding to changes in the environment, and they're getting tighter, as in your number of spots is less varied, and it's also decreasing. So from time 6 months to 14, significant difference, decrease. From 14 to 20, another significant decrease. What about up here? Did you have a significant increase when you had no predator when you split them? Well, these don't look like they overlap to me, so there's a significant increase. And then from here to here, though, this variation is large compared to the other after the split. And so this is what, 14 months and 20 months? They overlap. So even though there's an increase, it's not significant. So those are the kind of conversations you can have when you look at the error bars. So what we were looking for as far as where were you with your variation? Tons of genetic variation right through here. Huge error bars. Then you have these other mean number of spots, and they don't have hardly any genetic variation. So you don't have the big, huge range of numbers. They're tightly around the mean. So these fish are a lot alike. These fish are a lot alike. These fish are a lot alike. These have some variation, nothing like these. These are not, they're not alike hardly at all. Real different. So that's what you can do with error bars, and we're going to have a question about error bars on Friday.